So today we'll be talking about window functions. The last time when I was here, I discussed about aggregate functions and the difference between aggregate functions and functions that apply row-wise. So aggregate functions on the other hand, they run column-wise. So you just get a single value for all the values in that particular column. Okay, so what window functions now do is to allow you to still perform these aggregations or other functions across sets of rows, okay, without collapsing the result into a single row. So it allows you to apply your aggregate functions and other functions row-wise, okay? So you are not going to be getting a single answer, a single row as your answer, no. So you get the rows as they are. So that is what window function does. So we have some use cases. For example, let's say you want to rank students by score, or you want to do running totals of sales. You want to do a running totals of sales. You want to calculate moving averages, and you want to compare row values to group stats. For example, let's say you want to compare the salaries of people in a particular department to the average salary of that department. Yeah, so that's the meaning of that last expression. They compare row values to group stats. So what this is the syntax of Windows function generally. So you have a function name over an expression. So you have a function name into brackets expression, then you use over. So this over is very important. That is what identifies window functions. Because if you just write the function and the expression inside the function, that just works normally. So, but when you put over, okay, so when you put over, then it identifies that it works now as a window function. So there are two statements that you can have inside the over brackets. You can have partition by colon or order by colon. So what does partition do? It splits data into groups. So let's say you have a data of employees, and these employees belong to different departments, say HR, marketing, IT, and things like that. So partition by a particular column now groups that data. So if you partition by departments, what that does is it now groups the employees by their departments. Then order by other rows within the partition. So if you order by, that means that you want to arrange the rows within the partition. So let's say you want to arrange those employees according to their salaries. So you want to see those who earn more in each department. So you can arrange in descending order, starting from the highest to the lowest. So that will now be order by salary. Okay. So in each department that you are partitioned by, it now arranges each employees by their salary. So these are just examples. This is just an example rather to explain what a window function does. So it now depends on the function. So are you summing? Are you counting? Are you finding the maximum? Are you finding the minimum? Depending on the function that we have there. So we have different categories of window functions. We have the ranking functions, aggregate functions, and value functions. So let's start with ranking. So from the name ranking, it shows that it helps to arrange your data uh, according to a specified criteria. So we have the three ranking functions here. We have row number. So row number just gives unique number for each row based on the order. Then rank with gaps for ties. So what that means is if there are ties, it assigns the same rank for those values or for those entries that are tied. But now skip the ranking for the next number. So for example, this happens a lot during races. So when we were in school, when people run a race and two people tie, so let's say two people tie for second position. So you have the first position, and two people now tie for the second position. They are going to give the two of them second position. Okay? So, but the fourth person will now be giving what? So I want to hear from you guys. What would that fourth person be giving? Two people have already tied for second. The fourth person, what would it be giving?
I think they will still give that the fourth person third position.
Great. So if the fourth person is given third position, okay, that is dense rank. That means we have used dense rank. Pardon me, please. We have used dense rank because that one rank without gaps. So it's going to assign those two that tie the same position. Then the next person will be assigned the next number, which is third. But what rank does that is that it assigns the first position. Those two that tie, assign them second position. But that fourth person will now be assigned fourth position. So it keeps the third position. Do you get it?
Sorry,
So
please
that
come
is
again.
okay. So I'm trying to explain that the way rank works is that when there is a tie, okay, so the next position will be skipped depending on the number of ties or the number of entries that are tied. So if two people tied for second position, what rank does is that the next position will no longer be third position, but it will now be what? Fourth position. So it skips that third because it's believed that two people have already taken second position, which should have been second and third. Do you get? So it still counts them as second and third, but two people took second. So it skips third and gives the fourth person fourth position. So if three people tied for second position, okay, so that means you have first, then you have second. The next position will now be what? For rank.
Fifth.
The next position will now be what?
Fifth, I think.
Fifth, you are correct. Fifth position. So, but for dense rank, even if three people took the second position, that fifth person will still end up taking what? Third position. So it does not skip, it does not give gaps. So do we get the difference between the two now?
Yes.
Yeah. So, but for row number, whether there's tie or whether there's no tie, it just gives. So it just gives 1, 2, 3, 4, 5. So it's like when you have a serial number, okay? It will still arrange, but even if they are ties, it just gives any of them any number. It does not account for ties. Do you get? So we have an example here. let's say we have row number over, then partition by department, order by salary, DESC. Who understands what this code is doing? Anyone? Okay, so you notice that this code is ranking employees, and using the row number function. And now the employees have been partitioned by their departments, just as the example I gave earlier, but now ordered by their salary. So we probably, and the salary is ordered in descending order. So that means we're interested in knowing those that have high salaries in each department. Okay, so then it now assigns a row number to each. So that one does not account for ties. So even if two employees are earning the same salary, it will just give them number 1, 2, 3, 4, 5 till the last person in that department. Then when it moves to the next department again, it starts from 1, 2, 3, 4, like that, in that order. Okay, so that's that with ranking function. Now let's move on to aggregate functions. The most popular one, sum, average, mean, and max. There's also count. See? So we know what sum does. Sum adds everything. So, but for window functions, sum now does running totals. We use that for running totals. Then average, AVG, that is now used to calculate group averages without collapsing the rows. So let's say we want to get the average, salary per department. So here we have it in this example, AVG salary over partition by department. So we want to get the average salary by department, but we don't want to collapse the rows. So in front of each employee, you are just going to see another column that contains the average salary of the department that employee belongs to. So you can easily compare the employee salary with the average salary of his department. That can help you to see whether the employee is paid below average or above average. Then we also have the min max functions to check group extremes. So for example, I can use max here to check the highest salary per department. Yes, I can use max to check the average salary. Sorry, did I say average? I can use max to check the maximum or the highest salary per department. Yeah. Okay, let's move on now to value functions. So we have different value functions. We have lag. So lag helps us to get the value of the previous row. So when your columns have been arranged in order and you now want to get the value in the previous row, you use lag. While lead gives you the value in the next row. Okay, so lead can be useful for, let's say you are trying to calculate cumulative scores. You guys, or you're trying to calculate from cumulative frequency. You know, cumulative frequency is everything before plus the next value. Okay, so you can use lead plus sum to carry out that cumulative sum. Then first value, to get the first value in a particular partition, and last value to get the last value in a particular partition. So if I don't want to use min, max, I can use the first value here. But take note, the first value will be dependent on what you are ordering by. Okay, so the dependence on what you are ordering by. So in this example, we have lag order dates, 1 over partition by customer, order by order date. So that means you want to get the previous order that the customer made. Okay, so because you are partitioning by customer. Okay, so for each customer, you want to order by the order date, but you now want to see, okay, before that particular date, when did that customer buy last? So this one means that you are going one row backwards. Since it is lag, you are going one row backwards. If you make it 2, that means you are going 2 row backwards. If you make it 3, you are going 3 row backward, like that. And if it is lead, then it will be the other way around. 1 row forward, or 2 row forward, or 3 rows forward, as the case may be. So these are the key notes that we should bear in mind. Partition by and order by are optional in window functions. So if you do not put partition by, that means you want the window function to run through the whole data sets. Okay. Then for order by is also optional, but it is needed for the ranking functions. So that means if you want to rank, you want to do these ones, row number, rank, then you must always put order by. Okay, then window function run after where, group by, having, but before order by. Yes, so window functions run before order by, but after all of this. So if you're going to have any of this in your query, your Windows functions will come after them, because these ones run on the whole data sets. Okay, so while the window function also run on the whole data set, but since sometimes you might have to partition, do you understand? So it will now run on each group that's partitioned the data set to. So before you partition your data set, you should have carried out your where clause, your group by clause, your having clause before you now do partitioning with Windows functions. So in summary, window functions let you keep all rows while performing calculations, compare rows with group statistics, generate rankings, running totals, and comparisons. Yes, they simplify analytical queries significantly. All right, so now that we have introduced us to Windows function, let's take some examples in the data that we have been using for this Launchpad. So last week, you have been taught joins. So we're also going to do some joins here. And to save our time, I've actually written the codes down. So let's say you are interested in ranking customers by their join date. So you want to know, okay, who are our, who are our customers, like the customers that have been our loyal customers. Let's put it that way. Customers that have been with us for a long time. So you might want to rank customers by their join dates. Okay, so remember that we have the customers table. Let's check the customers table again. So in the customers table, we have customer ID, first name, last name, email, join date. The day they joined, they started purchasing goods or purchasing things from our e-commerce platform. Then the city they come from, the states, the country, and their loyalty team. So back to our file. Is it this? Okay, is this one? Sorry. So to do that, we'll select the customer ID, the first name of the customer, the last name, and the join date, because we need this. Then we now have another row. And this row now we want to rank our customer. So we're using row numbers over order the table by the join dates. Okay, because we're interested in join dates. And we're arranging it in ascending order. So remember, ascending order starts from the smallest to the highest. Okay. So that will help us to know those who have been with us for a long time. Yeah, and we name this row number, okay, from customer. So if we run this, we have this table here. So according to this table, we can see that our oldest customer is Ronald Phillips. He started patronizing us in September, okay, 9th of August, 2023. So he's not the only one. Another person also joined on that 9th August, which is Zachary Case. So you can see how row number works. Even though these two had the same join dates, he just assigned them numbers. So it does not take cognizance of ties. So let's say I now change this to rank. So I will see how each of these work. So let's change this to rank and let's see how it does. So we can see rank. Rank assigned these two. These two oldest customers as 1-1. So it gives them first position, both of them, because the join date is the same. And notice that the next person now is assigned third. So rank gives gap in its ranking. So let's use dense rank. So understand the difference. So you can see dense rank gives both of them the first position, then the next person second. Let me know if you understand this.
Yes, I do.
Okay. So no question. All right. So the next one is, what percentage of customers are in each loyalty tier per country? So back to the customers table. So we can see country here and we have loyalty tier. So we want to know how many customers in Canada belong to each of these loyalty tier, silver, platinum, bronze, gold, and so on. How many in USA also are here? So we can use the window functions, combination of it. So we are selecting from the customers table. Okay. We want to group by country and also group by the loyalty tier. So what are we selecting? We are selecting country, selecting loyalty tier. Now this group by is very, very important because you have an aggregate function here. Notice that this one is not a window function, it's an aggregate function. So you always have to group by. Okay. So we are counting the number of customers. So what this aggregate function does is it counts the number of customers per country in each loyalty tier. That is all. But in this case, we're interested in the percentage, not just the country. So this counts all times 100%, of course, to convert it to percentage divided by sum count. Now this counts. Okay, so we want to count over the country partition. So what this is doing is you are trying to get the number of customers in each country such that you can know the percentage of customers that belong to a particular loyalty tier per country. So that's why I named the percentage within country. Okay, sum over partition by country. So you are summing everything by the country. Okay, let's run this first. See. So as you can see here, we have the country. Canada comes first because we group by country and loyalty tier. So we have silver for Canada. We have 24 people. And this is 27.58% of customers in Canada. So 27.59% of customers in Canada belong to the silver tier. Then about 47% of customers in Canada belong to bronze. 6.8, or let's say approximately 7, belongs to platinum, while approximately 18 belongs to gold loyalty tier. Okay, so that is it. So by the time you add everything here, you should get 100% for Canada. Then it now moves on to UK and also does the same thing for UK. Everything here, all these whole percentage now should be equal to 100% for UK. So do we have any questions?
For now, there's no question from my end.
Okay, thank you. So then the next one is, what is the running total of customers joining over time in each country? What is the running total of customers joining over time in each country? So we are also selecting from the customers table. We need the customer ID, the country, because we're interested in the country, and the join date. Okay. So, but we are not interested in how many customers are joining per day for each country. So that's count star to count everything over. We are partitioning by the country because we're interested in each country. Then we're ordering by the join dates. Rows unbounded preceding means that it should always start from the beginning of the partition. Okay, that's the meaning of this statement. Always start from the beginning of each partition. So see this, take this as running total. Let's run this. Good. So we have this. So for Canada, by 9th of August, 1% joined. By the time it was 17th of August, we have had 2 customers from Canada. On the 31st, we have had 3. On the 4th, we've had 4, like that, like that, like that, like that, like that, like that, till May. I mean, till 5th of August, rather, 2025, where we now had total of 87. So that can help you to see the progression at which customers, we've been gaining customers from each country. And you also see that too for the UK. So we got 75 customers. So that is it for that one. Do you have any questions here? All right, so the next one is customer spending over time. So we want to see how customers patronizing us over time, like how much customers have been spending. So in this case, we also have to incorporate join because we are selecting from customers table, but we have to join to the orders table on customer ID colons, then also join the other items on other ID colons. Why are we joining so? So if you look at the customers, you notice that if you look at the customers table rather, you notice that you don't have any information about the customer spending. Okay, you just have details about the customer, but you don't have information about that. So you only have this information here, where you have the quantity that the customer bought, the quantity, the unit price, and the discount. But you notice that in this table, there is no customer ID. So you can't directly link this table to your customers table. So as an intermediary table, you have this orders table that contains the customer ID and what the customer ordered and how the customer paid. So you can link this orders table. So this order table will now be like a middleman between customers and other items. So you link customers to orders using customer ID because there's customer IDs in the customer table and there's also customer ID in the orders table. Then you now link orders with other items. So because there's other ID here and you have the details of the other ID here. Okay, so that is why we joined so. So I need the customer ID, but please, it's always good to use aliases here, because these aliases help your code to be more readable and succinct. Okay, so I'm using C to alias customers table, O for others table, and OI for other items table. So such that since the tables have the same columns, I can easily identify which column I am talking or I am referring to using the aliases. Okay, so I am getting my customer ID column from the customers table, the first name of the customer from the customers table, the order date. Then I have this function where I am trying to sum all of this. Remember, we in our last classes, we called this revenue. Okay, so quantity times unit price, then minus the discounts given. So I'm trying to sum this, but I want to sum over the partition of customers, but I want to understand each customer spending over time, like doing a running total of their spending over time. And I want to order by the order date. Okay? I want to order by the order date of each customer. So I alias this as running speed, running spend, I mean. So let's run this, see what we get. Great. So we have the customer ID, the first name, order date, and running spend. As you notice, you see that as the date progresses, we see how much Ronald has been spending. So that's like a cumulative sum. This is a cumulative sum, you see. Keeps on adding how much he spends per day. So that is it. And we can check that for other customers too. So the next question we want to answer is, who are the top customers in each country? Who are the top customers in each country? All right. So it's similar to what we have here. Here we had already summed the spending of each customer. Okay. So, but here now we want to rank that spending by the country. So I will know the top customers in each country. So the same join, okay? The same join, okay? So you have this sum, which is the total spend. But here now you are now ranking it. You are now ranking them. First of all, you partition by country and you order by the total spend, which is this expression here. The same thing as this one. So we're ordering by the total spend. So for each country, we want to order the customers according to how much they spend. So we know the top customers in each country, and is the ranking is in a descending order. Okay, so that we'll see those who spend more first. Then we now also want to group everything by the customer ID, first name, and country. So let's run this. All right, so what we have here is that Tina is the overall best customer in Canada. She has spent a total of 82,800. Okay, so I think this is the last example. Okay, no, second to the last. We want to find the number one product in each category. Now, how do you know the number one product? How do you tell which product is the most performing product? So probably you want to check the products that sell most. Okay. So the product that have lower shelf life that people come and buy quickly. So that might be your number one product. So that would be a criteria, and that's what we want to use here. So we are selecting from products table. I alias it as P, and we are joining into the others item table on product ID. Okay. So why are we doing that? Because we want to get the quantity for that product. So if you look at the products table, you just see you have details about the products, but you don't know how many of these products have been bought. It is this other items rather that can tell you the quantity, and it has product ID too that you can use to link with the products table. So that's what this join has done. So we are selecting category from the product table because we want to know the product in each category. So you see, your objective always determines what you're going to select. So you have to ensure that you have clear objectives while working with your data, so you know the SQL codes to write or the queries to write. I need this total sum of all the quantities for that particular product. Then I now want to rank. So I'm going to partition by the category because I want to know the number one product in each category, and I'm going to order by this sum so that the ones that have highest, the products that are sold most, okay, will be the number one, right? So that's why we're also using descending. So I arrange from the highest to the lowest. We name this, we alias this rank in category. Then I'm also trying to arrange everything to by the product category and the product name. Okay, so let's run this. So remember that group by always have to be there if you have a standalone aggregates function. If not, it's going to throw up error. So we have this. So as you can see, it has arranged my output according to the product category and product name. That's why apparel comes first. It's grouping by product name. So that is why we are able to count the total number of quantity per product name. Okay. So it has grouped position women. That's why it's able to count the total number of position women that has been sold. Then this rank has now ranked this total sales, telling us that for the apparel category, okay, position women is the number one product with 1,228 articles sold. So if we now move on to the next category, which is beauty, the top performing is Alone Makeup with 618 sold. Like that and like that. All right. So then to the last one. Let's say we want to get the first and last purchase per customer. So we want to know when was the first time a customer patronized us and when was the last time he patronized us. So that could be helpful. Let's say you want to know how long a customer has been, probably to measure the loyalty of your customers or your customer retention. Okay, so you want to see this customer that started patronizing us, how long did he keep patronizing us till he stopped patronizing us? So that could help you to really understand how well you are retaining your customers. So the customers table will help us to do that. But since we need the order date, we will be able to get that from the orders table, and we join that on customer ID. So we are selecting the customer ID from the customer's table and the first name of the customer. Then we use first value and last value. Remember, these are value functions. So first value of the order dates. Okay, so we want to partition by the customer ID and order by the order dates in an ascending order. So that will help you to get the first purchase, the first purchase date for that customer. Then for the last value, partition by customer ID, order by order date, but you now add rows between, let me make this come to the next line. Yeah. So you now use rows between unbounded preceding and unbounded following. So what this is doing is you are telling it that you should check the last value from the beginning of the partition to the end of the partition. Okay. So for each customer ID, check through from the beginning to the end and get the last value of the order date. From the customers table, I think I've mentioned that join to the orders table. So let's run this. Yeah. So as you can see now, we have the customer ID, the first name, Ronald. So Ronald first purchase was on the 14th of January 2023, and his last procedures on the 8th of November 2024. So that means Ronald has been our customers for a year plus. Yeah. Okay, so if you check here from our output here, you notice, for example, Jackson first purchase was in 11th of January 2023, and his last purchase was 29th of December 2024. So that means Jackson have been a customer for a year and almost 2 years. Almost 2 years. So a year and 12 months or 11 months rather. So almost 2 years, because by the time this gets to 11th of 2020, 11th of January 2025, that's exactly 2 years. So one can you can use this information to see how well we have been retaining our customers. Okay, so this is just examples of how SQL can help you to quickly gain insights from your data. So do we have any question on this last one?
No, not problem.
I don't.
Okay, okay. Thank you very much. So I'll stop sharing now and I'll hand over to Mr. Said.
All right, all right, all right. Thank you so much, sir. I really appreciate your effort. So we attendees, I will urge us all to grab this opportunity to utilize it to the maximum of learning SQL, starting from the basic select and where clauses that we started, down to the aggregate function, down to the subqueries, down to the join clauses, and finally to the window function. For those of us here that we are yet to watch the videos, as in the recorded videos, I'll urge us all to take advantage of that. Don't just view it like it's optional. SQL has been in existence for years, and trust me, it's going nowhere. For you to be a good analyst, or for you to work in data feed generally, whether you're a data analyst, as in whether you're a data engineer or data scientist, you have to come across SQL in your journey of data. No matter how, you have to come across SQL. So you having the knowledge or the basic knowledge of SQL, it's an advantage as an analyst. Take for instance, you find yourself in an environment or in an organization in which their major language that they are using for their database is SQL. As a data analyst, you can't be waiting for a data engineer to do your job for you. So you're able to fit in perfectly in those kind of environments or in this kind of organization. So I will urge us all to take advantage of this opportunity. Learning, we learn by practicing. Learning sticks by practicing. All what you've taught, if you are not that clear with some parts, you can just simply type it to the group and you'll be attended to. Likewise, aside us just bringing you how to use clause statements, from statements, and everything like that using this practice projects, you yourself also will urge us all to work on individual projects because there you learn a lot. Things might run from Sir Isaiah workbench successfully without any throwing any error. But when you are repracticing it or when you're working on another project on your own separately, you will find out that things are not working that way. And from there, you learn more. You learn a lot from there. So I'll urge us all to kindly use this opportunity because it's very rare for you to learn SQL for free and for you to still have a good mentor to still put you through. It's very rare. So don't let us just say, okay, since the program is for free, I can just do it a while and leave it. Trust me, paid program that there people are paying thousands for are no more than this for SQL. Because for any language you are learning, if you can grasp the basic very well, if you have a solid foundation of the basic, trust me, irrespective of how well you find yourself, you're able to thrive. Irrespective of how the problem looks like when you're in your workplace, you're able to prefer solution to it just because of that strong basics you have. Say for instance, we're in the world of AI. Anybody can just go on the ChatGPT, Cloudy, blah 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 like that and just put things up and everything like that. But trust me, when you like the basic, no matter how ChatGPT won't solve your problem, no matter how Cloudy won't solve your problem, likewise other LLMs. So let us utilize this opportunity to its maximum. So that will be my advice in that phase. And finally, also, I would also like to tell us that for the SQL Launchpad program, will be coming to an end today. This will be our last session for the program. So for those of us that we are yet to catch up, let's try our possible best in catching up with the remaining recorded videos that we are yet to watch. You can find all those videos on our YouTube channel, Inside Data Academy YouTube channel. All are there. So you can access them from me as from there. And anywhere you're having issue, please kindly forward it to the group. We'll attend to that. So if there's any question, maybe for me or for Sir Isaiah, you can simply tender that so that we can call it a day. Thank you so much.